My name is Prakash. I am from Bangalore ADC. We are going to demonstrate continuous jute polypropylene thermoplastic. Okay, we are feeding continuous rowing into the extruder, and then when the polymer melts, and polymer will be melted in the jute and finally compounded, and the pellets will be comes out, and we are feeding polypropylene from the first feeder. And once the polypropylene comes into the feeder, what's happening when the pellets will be melted? What's happening? The pellets has to melt into a continuous phase. We are using a fractional kneading block so that it melts continuously, and then once the melting takes place, what's happening? Then the fiber is introduced into the second zone, so that once the fiber comes and the polymer has to massacate into the pellets, and the distribution of the fiber will takes place. Here what we are doing here, and you can come slowly, so that what we are doing, we are feeding the pellets in the intake zone, melts the polypropylene. Once the polymer melts here, and we are introducing the jute, long continuous jute here. Once the jute comes out here, and the polypropylene, melted polypropylene coated on the jute, distribute the jute, and the wetting of the jute will takes place. And here what's happening, we are not pre-drying the jute. Most of the people are pre-dry the jute, because again it is energy saving, and we are not pre-drying, we are not distributing the jute, continuous jute fiber, and we have the wave elements. There is a special elements to wet the fiber, and it will not break the fiber, it continuously distributed devam. And here this jute had 20% of moisture. Removing the 20% of moisture is very difficult. What we are using a vacuum port. There are two vacuum ports, removes the volatiles, removes the moisture from jute, and finally when it comes to the exit, here you can see the strands are quenching into the tank, and it is going. Once the pellets comes out of the extruder, what's happening, there is a moisture will be come down to 0.33. That is a good thing, because when down the line it is 20%, and finally it is coming to the 0.003%. And once it is quenched, strands will go there, and there is a air knife. What the air knife is doing, it removes surface moisture. When the strands are having water, that has to be removed, and the surface removal has to be taking place, and finally it goes to the pelletizer. Sear has developed the new pelletizer to pellets. Pellet can be cut into the 7 to 8 millimeter length, and you can see the pellets over there, and that pellets will be collected here, and finally it goes to the injection molding. So once it comes from the exit, you can see the pellets here. The longer pellets will be 7 to 8 millimeter length of the fibers. You can see even the natural jute color will be the same thing. There is no degradation of the jute, and normally when the temperature shoots up to 200 degree, the fiber will degrade. But the unique nature here, we are using a OSC element. That OSC will take the lesser heating, and it is not producing any color over there. Here see the color of that. And finally I will take into the next section. Once we have done some of the injection molded, after doing the pellets, we are doing some of the injection molded parts. One of the parts is here with me. It is for the it is a freezer, the stand, and again we are done the micro oven parts here for the rice, micro oven for the rice cooker. This is a rice cooker we have done by using the jute. This had 30% of the jute, and again we have done some of the parts. See, depending on required color, you can add the pigments, and finally you can get the color out of that. But normally when you feed the jute color will be on what is the actual natural color. When you want a different color, you have to add the pigment into that, you are going to get the color out of that. And these are some of the automotive parts we have injection molded here. And again, see, these are the special elements we have used for fractional kneading block elements for use jute, and these are the OAC elements so that it can wedge the fiber into the polymer. Okay. These are the dashboard. We have injection molded part is here. It is so lightweight when compared to the polypropylene. So in automotive industry, you can see the fiber, how the fiber is here. These are the continuous fiber, jute fiber length, see that. And distributing the jute is very critical. The OAC elements is able to take care of distributing these fibers into the polymer matrix, and then you can see that there is no rough surface on the strand, there is a smooth surface on the strands or they, and for the polypropylene jute. This is the continuous jute what we have done, and see that's how the surface after molding, the injection molding.